I'm back. Okay, so now we're going to look at this definition, and you're probably going, whoa, why is it different, Torres? You just use x's. And so they're going to mix it up with Anya a little bit every once in a while. And so instead of calling the point x and f of x, they might refer to it as c and f of c. But you can see over here that, haha, c, get it? Just kidding. So over here, where I would have had an x before, now I have c, so it's now c plus delta x instead of x plus delta x, and then minus f of c where before I had an x. It's still the exact same formula, don't freak out. Okay, I'm turning the page. So, of course, it's possible to have a vertical tangent line. An example might look like this. So if I drew in the tangent line at this particular point right here, I would actually get a vertical tangent. Awesome, huh? Okay, so it exists when the function is continuous. So my purple function was definitely continuous at c, and I get a limit of my y value going to either positive or negative infinity. Remember, this represents slope, so if I have a vertical line, before you've known that as an undefined slope, but that's because it's going to either positive infinity or negative infinity. Both, I guess, technically. So just checking to make sure that you remember how this is read. It is the first derivative. I can tell because I have one little tick mark. So I can refer to it as first derivative, or it's read f prime of x. So that's how you read it, f prime of x. We'll usually probably call it just first derivative, but every once in a while you might see that. And so of course I already have the definition, and of course they can't be happy just giving you one version of it. So another version that we are going to use as we start out actually calculating the slopes is we're going to call that distance between the a and the b value, where we were calling it delta x before, we're going to call it h a lot. And so it's now going to look like this. So instead of delta x, I'm replacing all the delta x's with h. Notice, other than that, still the same formula. And since I'm calling that h, then I want h going to 0, where before it was, actually should have been delta x going to 0. Okay, so now this next set of directions looks a lot scarier than it is. However, I will tell you that some of you were still struggling with writing the equation of a line, which we discussed in the preview chapter. And so this is going to bring back into your memory bank how to write the equation of a line. So if I want to write the equation of a tangent line, a line is a line is a line is a line. So the easiest form is point slope form, and that's my point slope form using the point C and f of c. So the first thing I'm going to have to do is find my point, and I'm going to assume that they give me an x value. So of course I'm just going to plug in that x value to get the y value. So if the x value is c, I'm plugging in c to get the y value. Next I have to find the slope, but now I know that this is the derivative, and then I'm going to use that slope and that point to substitute into point slope form. So I'll be substituting in the slope, and then I'll be substituting in the point c, f of c, into point slope form. Easy peasy, guys. And this is just some vocab. So another way of talking about it is the derivative of y with respect to x. Sometimes instead of calling it f prime of x, we'll call it dy dx. Remember, that's really change in y over change in x, similar to delta, we could just say that. And so derivative of y with respect to x, derivative of y with respect to x.